Hello, PreCalc. I had to do quite a bit of taping in class today due to some absentees, so I'm not sure how many minutes I have left. So here goes it. Hope I do a little better on the date today. And I hope it gets uploaded well. All right, we're going to look at where we can actually use base E. Problems that use base E. And we talked about E being approximately 2.7, and the decimal representation goes forever, never ends, and never repeats. Let's look at interest. Suppose that you made an investment that was miraculously making 50% every year. Once a year, it calculated 50% of what you had invested, and it added 50% of that each year. So we're going to say the amount on time zero, A sub 0, is P. That stands for the principal, or what you've had to start with. So on the very first day of this amazing investment, you have A sub O equals P. And 1 year later, the amount at time 1 year, it's going to be P, what you put in, plus 50%, or 0.5 times P again. So simplifying that, I can factor out the P, and I get 1 plus 0.5 when I do that. Or you can think of just adding 1p plus 0.5p is 1.5p. All right, so that's simplified, whichever way you want to look at it. Let's see what happens the second year. So the second year, we have ended with 1.5p, and then we're going to add 50% of that whole amount. So 0.5 times 1.5p. And when I do that, I end up with 1.5p. I'm going to factor it. 1.5p is here and here. So if I pull out a 1.5, factor out a 1.5, I've got a 1 and a plus 0.5, which is equal to 1.5 p times 1.5. All right, so I can combine these two 1.5s and get 1.5 squared, which I can improve on, but I will not. I'll just leave it like that. So that's what I got in the second year. So notice first year, second year. All right, it's not going to surprise you, I don't think, being the pattern finders that you are, that I'm going to take the result of year 2, 1.5 squared, times P, and that's what I'm going to have to start with, and I'm going to get 50% of that added to my total. So I can factor out a P and a 1.5 squared. So I took that one out and that one out, and it's left with a 1 and a plus 0.5. And so I get P times 1.5 squared plus 1 plus 0.5 is another 1.5. So I get P times 1.5 cubed on the third year. So as you see this discussion go, you can probably tell that the amount at any time t, is going to be the principal 1 plus the rate of interest. Ours was 0.5, so we had 1 plus 0.5. For any rate, I'm going to write it like this, raised to the time t. All right, so that is a general equation for compounding interest once a year, which is very unusual. Usually, the interest is compounded more than once a year, perhaps quarterly, which would be 4 times a year, or monthly, which is n times a year, or continuously, which is an infinite number of times per year. So let's improve on this formula. Here's what it turns to. The amount of money is going to equal the principal, the 1, but we're going to take the rate. If we're going to do it more than once a year, we're going to divide it by the number of times per year. So this is the rate of interest. This is the number of times it's compounded each year, calculated. Number of times compounded, we call it, per year. Number of times compounded per year. So monthly, this would be a 12. Quarterly, this would be a 4. And that's going to be raised because of the change in the number of times. It will be raised to the n times t, where t is time. All right, so let's use that equation and for our assignment. All right, so you heard me talk about compounding interest for once a year. If it was semi-annually, twice a year, 2, quarterly, 4, monthly would be 12, and could be even daily. So this could be a 365. So what would it look like if I compounded it continuously? So I'd be calculating the interest at all times. So let's see what that would look like. What happens here? We're going to take this equation from above and I'm going to make this substitution. I'm going to say that n is going to be replaced with an expression called mr. And just allow me that, and you'll see what that does for us. So whenever there is an n, I'm going to replace it with this expression mr, and I'm going to raise that to the mr because there's an nt. The reason I did that is because this expression can be rearranged so that we can have 1 plus, the r's will cancel, and I have 1 plus 1 over m raised to the m. I'm going to group the m part of that exponent with this expression to the rt. Now we talked about this expression today in class, and that's the one where somebody put in a 10, somebody put in 100 and 1,000 and so forth, until we saw that this expression, as m goes to infinity, or as it gets higher and higher, it approaches e. So that's what's going to happen as we repeat this over and over hundreds and thousands and billions of times at all times continuously. This goes to e. So this is the equation for continuous compounding, PERT. But notice the p and the e, and the rt is the exponent of the e. So p e raised to the rt, where e is that natural number, e, 2.7. P is the principal, r is the rate of the interest, and t is the time. All right. So those formulas will help us through our assignment. I'm going to shut this part down and see if I can eke out another part.